Good morning children and welcome back to your chemistry class. So we had already begun with this new chapter, alcohols, phenols and ethers, where we had begun with alcohols. So in the last video we had studied about what are alcohols and how are they classified. Today we are going to in this video talk about the preparation of alcohols, but before that let us study about the structure of alcohols. So in alcohols, the oxygen of OH, it is attached to the carbon, right, and hydrogen, and it has a lone pair. Clear? Now this oxygen is attached to this carbon by a sigma bond, and this oxygen with this hydrogen with a sigma bond. This carbon has sp3 hybridization and oxygen also has sp3 hybridization. How does oxygen have sp3 hybridization? You already know that atomic number of oxygen is 8. So it forms 1s2, 2s2, 2px2, 2py1, 2pz1. So what kind of hybridization is it showing you? It is showing you sp3 hybridized. Clear? Thus, what do we see here? If it is sp3 hybridized and carbon is sp3 hybridized, then the structure that is shown over here is a tetrahedral structure, and tetrahedral structure has what angle? 109 degrees, 28 prime. But what do we see over here at oxygen? There is a lone pair. So because of the lone pair, what happens? When the lone pair is there, then repulsion takes place. So when there is repulsion, the angle decreases, and instead of showing 109 degrees 28 minutes, it shows what? It forms an angle of 108 degrees 9 prime. Okay. So I hope the structure of alcohol is clear to you. What did we discuss over here? That oxygen is attached to carbon with sp3 hybridization, and with the sigma bond with hydrogen also it is combined with the sigma bond, and oxygen also has sp3 hybridization, and therefore it shows a tetrahedral structure. If it shows a tetrahedral structure, what angle should it form? 109 degrees 28 prime. But because of the lone pairs, there is repulsion. So when there is repulsion, there is a bit decrease in the angle. So instead of 109 degrees, it forms what angle? 108 degrees 9 prime. Followed? So this was all about the structure of alcohols. Now we are going to talk about the preparation of alcohols. So there are different methods that we have to study in the preparation of alcohols. For example, like the first method could be by acid catalyzed hydration of alkenes. Okay. The second method is by hydrolysis of haloalkanes. There are about 6 to 7 methods that we have to study. Then next one is by reduction of carbonyl compounds. Then fourth method is by reduction of carboxylic acids and their derivatives. Then the fifth method is by hydrolysis of esters. Sixth method is by reaction of Grignard's reagent, and the seventh point is by aliphatic primary amines. Okay, so these are the 7 methods by which we have to understand to prepare alcohols, and we are going to complete all these 7 today in this video. So let us begin. First method of preparing alcohol by hydration of alkenes. Now this takes place by 2 methods. One is your indirect method, okay, and the other is your direct method. So first let us understand the direct method, and then I'll explain you the indirect method. In the direct method, the alcohol can be formed by the direct addition of water molecule to any of the reactive alkenes in the presence of catalyst. Okay, so this is A, this is the B part. So let us talk about the direct method first. So over here alcohols can be formed how? By direct addition of water molecule to a reactive alkene when in the presence of a catalyst. Okay, so this is your direct method. For example, like if I take this compound CH2, what is the name of this? It is propene. When treated with water in the presence of a catalyst, it is going to give you propane 2-ol, that is CH3CH, CH3CH, CH3, and your OH. This H will get attached to this carbon and OH will get attached to the carbon with less number of hydrogen atoms. Clear? Now let us see the indirect method. In indirect method, what do we study? That the addition of water molecule to an alkene can be carried out by first passing it through concentrated sulfuric acid followed by hydrolysis with boiling water. Okay, so let's look at the reaction. That is, if we take ethene, CH2 double bond CH2, and we take sulfuric acid. Sulfuric acid can be written as HO SO2OH. See, H2SO4. Then in this case we get an intermediate compound which is called as ethyl hydrogen sulfate, that is CH3CH2 and now OSO2OH. This is your ethyl hydrogen sulfate. Okay, so further, this on boiling with water, it is going to give you ethanol. That is CH3, CH2OH and sulfuric acid will be given out. Okay, so this is the indirect method. What? That addition of water molecule to this alkene can be carried out how? By first passing it through the sulfuric acid followed by the hydrolysis with the boiling water, and it will give you ethanol. Ethene will give you ethanol. Clear? Now, in unsymmetrical alkenes, this was a symmetrical alkene. Now let me take an example of an unsymmetrical alkene over here. In unsymmetrical alkene, let's see, like CH3, CH double bond, CH2. Okay, this is going to follow Markovnikov's rule. The unsymmetrical alkene is going to follow the Markovnikov's rule over here. So HOSO2OH. What is the Markovnikov's rule? That this will get attached to that carbon which has lesser hydrogen. Okay, attached to the double bond. So it is going to form CH3, CH3, and it will get attached to this carbon forming SO2OH. And further hydrolysis of water will give it CH3, CH3OH. This is called as propane 2 all will be formed. Okay, so this was your example when we have an unsymmetrical alkene and it follows Markovnikov's rule. Okay, now let me explain you the mechanism of the acid catalyzed hydration of alkenes. Okay, so this takes place in 3 steps. The first step is protonation of alkene by electrophilic attack of hydronium ion. Okay, so over here, firstly hydronium ion is formed how? When we add water to any salt, when we add water to any acid, what are we going to form? We will form hydronium ion. We form, this is clear. Now this hydronium ion is going to attack the alkene. So let us see this. See, this is the hydronium ion, HOH, but it has a positive charge over it. It will attract the electron and this hydrogen will move to the carbon, right? And therefore it is going to form a carbocation. So look at the carbocation formed over here now. It will be forming C, H, this is C, this H comes here, carbon, and water will be formed with the lone pair. Okay, now moving to step 2. This is nucleophilic attack of water on the carbocation, right? So this is your carbocation, and nucleophilic attack of water on carbocation. So this oxygen has lone pair, it needs positive charge, so it will attack the carbocation, right? and what is it going to form? CH. Water will get attached to this carbon. OH, H. This becomes positive ion, comes on oxygen. Right? Now comes your third step. Third step is what? Deprotonation to form an alcohol. Right? So over here what happens? Look at the structure. CH combines with water, which has the lone pair. It has a positive charge over here, so it will attract the electron from its bond. And where will this hydrogen go? It will be attracted by this lone pair over here. Thus, what does it form? An alcohol. That is CHCOH. Okay, and since this hydrogen moves this side, it will again form the hydronium, positive hydronium ion. Right? Now, this first step is your slow step, and the other two are your fast moving steps. Clear? So this was the mechanism of the acid catalyzed hydration. Second one, we are going to do the preparation of alcohols by the hydrolysis of haloalkanes. Okay, so haloalkanes over here, they are going to yield alcohol on the treatment with dilute aqueous solution of potassium hydroxide. So let us see the general reaction first. This is what your haloalkane, when it is treated with potassium hydroxide, what is it going to form? See, it is going to give us ROH. This is the alcohol I was talking about. Alcohol plus KX. The alkyl halide will be given out. So let us take one example over here. Like I take chloropropane. CH3, CH2, CH2, Cl. Haloalkane. This is an haloalkane. Okay. What is the name of this? Chloro, because position of chlorine is 1, so I am not writing over here 1. Otherwise, it should have been 1-chloromethane propane. 1-chloropropane when treated with KOH. So this is the alkyl halide it is going to form, and this is the propanol will be formed by it. So the formula becomes CH3, CH2, CH2OH. This is called as propane 1-ol plus KCl will be formed over here. So this reaction can also be carried out during the aqueous solution of either potassium or sodium carbonate also, or even the moist silver oxide. Okay. Always the final product in all the cases, it will always be alcohol. Over here, one needs to remember that the reactivity of alcohol towards hydrolysis will always follow this trend, where your alkyl iodide will be more hydrolyzed than bromide than your alkyl chloride. Okay, so this is the sequence of the reactivity of haloalkanes towards the hydrolysis. Which one will get hydrolyzed more easily? Iodide, followed by bromide, and lastly the chloride. Okay, then let us come to the third method we were talking about, that is preparation of alcohols by the reduction of, which one was that? Okay, carbonyl compounds. Okay, so let's look over here. Over here the aldehydes on reduction, they give the primary alcohols. Okay, ketones, they give the secondary alcohol. So I'm writing it down over here so that you remember. Aldehydes, they always give primary alcohols, and ketones, they always give secondary alcohols, right? So what is the common reducing agent that we are using over here? The common reducing agent that we use over here is your sodium. Got it? And alcohol. Or it could be hydrogen with any of the metal catalysts, that is with platinum or palladium or nickel or any other metal we were talking about. So let's see over here. Let's look at the general formula first. So RCHO, what is this? Your aldehyde. Okay, this is your aldehyde when it is treated with, say, hydrogen. Okay, in the presence of say, I'll take platinum. So what did I say? We are going to get primary alcohol, that is RCH2OH. This is your primary alcohol. Okay, so let's take an example over here, like ethanol, CH3CHO. CH3CHO, what is this? Ethanol. Ethanol, when it is treated with hydrogen along with one of the metallic catalyst like platinum or any palladium, it should give us what? Ethanol. So this gives us CH3CH2OH. Fine. Then let's look at ketone over here. Ketones are going to give us secondary alcohol. How? This is your ketone. Okay, I'm just showing you the general formula first. So this is your ketone. When this is treated with hydrogen along with one of the metal catalyst, followed, let me write like this. So what it should give? It is going to give us RCHOH. Okay, this is what? Your secondary alcohol formed. So let's take an example of a ketone, if I take C double bond O, this becomes your CH3CH3. What is the name of this? Methane, ethane, propane. So the name becomes propanone. Okay, when treated in the presence of hydrogen and the metal catalyst, it should give you what? CH3CH3CHOH. Now methane, ethane, propane. So what is it going to give you? Methane, ethane, propane. At 2 you are getting the alcohol. So this was propanone 1 or propanone, and here you get propane 2 all. So this is your secondary alcohol formed by ketones. So I hope this is very clear to you that alcohols by the reduction of carbonyl compounds, that is with aldehydes, you always obtain primary alcohol, and with the ketones we always obtain the secondary alcohol, right? Now let us move to the preparation of alcohols by reduction of carboxylic acids. Preparing alcohols by reduction of carboxylic acids. Okay, so over here the acids and the derivatives, like they could be your acid chloride or anhydrides or even esters, they on reduction, they always produce alcohols. Now for reduction, what did I tell you in the previous reaction? That reducing agents could be your sodium along with alcohol, or it could be hydrogen along with any metal catalyst, that is your platinum or palladium, right? Or it also could be lithium aluminium hydride, that is also possible as a reducing agent over here. So let us look to all the general formulas. So the first one, as I told you, reduction of carboxylic acids. Let me write down, and their derivatives, so it will be more clear to you. So over here, let's take a carboxylic group like RCOOH. This is what? Carboxylic acid, right? So this gets reduced. What did I say? I did not use this, so let me use lithium aluminium hydride over here in the presence of hydrogen. Okay, so what it should give you? Let us see. R is there, so RCH2OH, that is your primary alcohol will be formed along with release of water. Then let us look at acid chloride, that is RCOCl. This is your acid chloride. Okay, then let me change your reducing agent. It could be H, and palladium is over here. Okay, so what is it going to give? It will give you alcohol RCH2OH plus HCl will be formed. This is also your primary alcohol formed by acid chloride. Then another one could be with the ester, like RCOO R dash. What is this? This is your ester on reduction with your lithium aluminium hydride. It is going to give you mixture of alcohols, that is RCH2OH plus R dash OH. RCH2OH and R dash OH will be mixture of alcohols will be formed. Okay, mixture of alcohols will be formed over here. So I hope you have understood how to obtain alcohol by the carboxylic group. What are the different reducing agents that could be used to prepare the alcohols? Okay, now the fifth one could be hydrolysis of ester. Now here it was reduction of ester. Now I'm going to talk about hydrolysis of esters. So when esters, they are refluxed with dilute solution of an acid or maybe an alkali, then they hydrolyze to give their parent alcohol, and then acid will be formed over here. So let us take an example over here like ethyl ethionate if I take. So CH3COOC2H5. What name did I give it? Ethyl ethionate. Ethyl ethionate when treated with water. Okay, in the presence of what? It could be a dilute solution of either an acid or an alcohol over here. Then it is going to hydrolyze to give you the ethanoic acid, and ethanol will be produced. So this gives you CH3COOH plus C2H5OH. This is the alcohol that is formed over here. So this is your ethanoic acid and this is your ethanol. Clear? I hope the hydrolysis of esters is also clear. Then next we come to preparing the alcohol by primary amines. By primary amines. So what are primary amines? primary amines like, for example, C2H5NH2. This is called as thenamine. This, when treated with nitrous acid, that is HNO2. What is this? This is your nitrous acid. It will always give you, primary amine will always give you primary alcohol. This is your primary amine, which is also going to give you a primary alcohol. So what is your primary alcohol? C2H5OH. C2H5OH plus nitrogen will be given out plus water, and this is called as your primary alcohol. Followed, what is the name of it? Ethanol will be formed here. So remember, in this method, the nitrous acid, it is produced when sodium nitrite and hydrochloric acid, they are added to the mixture. How is this nitrous acid formed? So remember, this nitrous acid will be formed how? When NaNO2, that is your sodium nitrate, is treated with HCl. Okay, then it forms NaCl plus HNO2. This is how the nitrous acid is obtained over here to be treated with the primary amine. So I hope till here it's clear. We move to the last method of preparing alcohol, that is from the Grignard's reagent. Okay, so now coming to the seventh one, that is preparing alcohol from Grignard's reagent. Okay, so let's see the first one. Let us see how the formaldehyde or methanol, it is reacted with Grignard reagent to obtain what? The primary alcohol. So what did I say over here? Over here I said your methanol or the formaldehyde, it is always going to give you what? Primary alcohol. All this is very important. Which reactant is going to give you primary alcohol or secondary alcohol, tertiary alcohol? All this is a must to be remembered. Then only the reactions will be easy for you to understand. So over here, as I said, what? That methanol or the formaldehyde, when it is treated with the Grignard's reagent, it is going to give you primary alcohol. So let us look over here firstly with the general formula, and then I'll show you the reaction. So HCHO, when treated with what is Grignard's reagent? RMgX. Okay, so firstly it is going to give you what? An intermediate product will be formed. What is that? That is RCH2OMgX. Now OMgX, this is what is going to be formed as your intermediate product. And further, when it is decomposed by water, okay, it is going to give us primary alcohol. That is RCH2OH plus MgOHX. So let us look at the reaction over here. Let me show you the methanol, how it can be written. It can also be written like this, isn't it? Over here, if you see, this has a slight negative charge and this has a slight positive charge. And this is what? Your methanol. Okay. When this is treated with Grignard's reagent. So Grignard's reagent, let us take CH3MgCl. Okay. So this is going to form what? The intermediate product will be formed over here. What is that? CH3CH2OMgX. Right? Further gets decomposed by water, and what is it going to form? It will form RCH2OH, that is the alcohol, plus MgOH and what is there? Chloride. This is called as hydroxy magnesium chloride will be formed. Now for next, this was first reaction. Then we can also see the aldehydes, that is RCHO. They will always give us secondary alcohols. So let's take an example over here, like RC double bond OH. Okay, this is your aldehyde. When this is treated with your Grignard's reagent, okay, it is first going to give you the intermediate product R dash CH single bond. Where will this R go? It will come here. OMgX. This is an intermediate product formed, okay, where this is minus and this is plus over here. Getting decomposed by water and it is going to form secondary alcohol, that is R dash C R H OH plus MgOH. Got it? So this is what your hydroxy magnesium halide, and what is this? This is your secondary alcohol formed over here. Then let us look at the ester, that is RCOR dash. This is going to form your tertiary alcohol. So formaldehyde or methanol, it is always going to give you primary alcohol. Any other halide except formaldehyde or methanol, they are always going to give you secondary alcohol over here, right? And lastly we come to ester. Ester will always give you the tertiary alcohol. Take one example over here, like CH3 C double bond O CH3. Okay, so this when treated with your RMgX. Now I gave you one example over here. You can take this example over here for your Grignard's reagent. Okay, it could also be like CH3 MgI or MgBr. All these are your Grignard's reagent. So what is the name given to it? Methyl magnesium iodide. This is your Grignard's reagent, methyl magnesium chloride, methyl magnesium bromide. These are all your Grignard's reagent. So over here, when it is treated with the dry ether, right, it is going to give you the intermediate product. What is the intermediate product? Let's see this CH3, CH3, then CH3, then OMgX, OMgX. This is your intermediate product is formed, which further gets decomposed by water to obtain the tertiary alcohol. Let's see the tertiary alcohol obtained over here. CH3. This could be brought CH3, CH3. Tertiary alcohol OH. What is the name of this? 2-methyl propane 2-ol. Okay, plus your MgOH(X), right? So what is this? This is your tertiary alcohol formed over here. So with this we finish off with the different methods of preparing alcohols. Thank you.